Okay, so for a long time in my life, I was kind of like easily distracted and kind of discouraged from trying to solve big problems. And I really wasn't an analytical thinker or really talented in math or anything like that. So I was always doing poorly in courses that required real skill in solving problems, things that like had a definite answer. So always very good at the ones that you could be subjective in what you were saying, like history or English or writing or anything like that. But there's always these quantitative and hardcore courses that I was always struggling with. So I thought I'd make a nice little video that kind of explains my process for solving these problems and how to do well in math and physics and programming, how to do those things if you're someone who tends to be pretty bad at it, because I was like that. And really it's taken several years of learning things that have kind of helped me get better at that. So the first real piece of advice that I'll say is when you're solving something that's really complex, and it doesn't have to be like a Nobel Prize problem. It could be something like factoring or, I don't know, solving a calculus problem. So how do you get started in that? I run into this a lot with students in tutoring, and the first thing I say is, let's just try and figure out what's the first step that we can make. What's the most basic step in the problem that we can make? Because what you do when you do that is you take this huge overarching problem and you break it down into smaller and smaller and smaller steps. And that's really the key to problem solving. And so how can you do that? Well, I really do, this sounds really trivial, but maybe it will help someone. I really do think that just keeping a blank piece of paper and writing down everything that you're thinking in the beginning of the problem, and then kind of looking at all those different ways that you would start the problem, and then trying to narrow it down. And the reason I say like this really big overwhelming idea of writing everything down is because the more that you do this, the less you'll end up writing down. And so naturally over time, you'll get better at this and you won't have to write down as much. So for example, like here's a real scenario. In my case, when it comes to programming, I used to have to write code. I used to have to take a piece of paper and write code down, because it just took me becoming comfortable with syntax, being like, okay, this opens here, this closes here, and then this symbol comes before this, and this symbol comes before that. And I think sometimes people just expect that to come to them. And for someone like me, it's certainly easier now, but in the beginning it was always, okay, what are these key words? What are the fundamental key words in this language? And I had to understand the syntax of a programming language before I could even think about anything like object-oriented programming or anything like that. So my first suggestion is definitely just get a piece of paper and be very comfortable with writing things down that you might not ever even need. You might end up throwing it out. You might never even need that piece of paper, but what happens is you're making a mind-to-hand connection with whatever it is that you're trying to learn. So it doesn't have to just be programming, it could be math. I was never really good at math in high school, but then slowly by writing things down over and over again and just becoming familiar with the language of mathematics, I walked out, was able to get my degree in physics and solve what I would say are pretty complicated math problems, like partial differential equations and stuff like that. So I think that is probably a really good key. Okay, so the other thing is you have to be immersed in the language of whatever you're trying to do. So don't think of technical things as something that's like really crazy and impossible to understand. It's a language. It's always a language. Linear algebra is a language of math. Calculus is a language of math. There's programming languages. They call them languages on purpose because they're languages. They're jargon and syntax and symbols that are used to take abstract ideas and make them more understandable. So you have to be comfortable with the language. You can't just expect that you're going to walk into class and then all of a sudden just get it. That might happen for some people, but if that's happening, that's already probably happened for you. And if you're struggling with that, then what I recommend is sitting down, and this is a really good technique that comes from a book called The Mind for Numbers from Barbara Oakley. It's a very helpful book that I read. It's called The Mind for Numbers. What she recommends is whenever you're going into lecture, you read the chapter beforehand. And the way that you read the chapter is pretty important. So you want to break it up in parts so that you can finish the whole entire chapter before you go into class. That way, when a professor's speaking or if you're watching a video, you're able to make mental connections with what you read and what they're saying. So it's not always coming from either the text or from the teacher. You're taking both and you're meshing them together. And the way that you read the text is pretty important too. It's very helpful if you take it and you quickly go through and you look at all the bulleted words, graphs, figures, just read some of the stuffs, and go through and just kind of create a map for how you're going to read the chapter. So when you know that you're going to be looking at something involving probability, you're already kind of jump-starting your mind into thinking, okay, I'm probably going to be running into something about probability later. It's not going to hit you as a surprise. And then all of a sudden you're going to be overwhelmed with how much stuff that you weren't expecting. It's like you kind of anticipated. Then once you're done, a really, really helpful thing, probably the most helpful thing, and all my students who do this in our tutoring sessions, they always see a huge improvement in their grade, is going back through and actually explaining what the concepts are to yourself. And I understand it's a time-sensitive thing, so you might not have enough time to go through the whole entire chapter all over again, but at least go back to the beginning, because by the time you finish the chapter, all that stuff in the beginning is probably mush. So that's my other tip. And I really think that the last piece of advice is probably the most cliche piece of advice, but it really is very important. Practice. Practice makes perfect. When it comes to programming, if you're writing programs from scratch, it will help you read and write code. I know everyone says, oh, all you have to do is copy and paste. Okay, well, what if you don't know how to read the code? How are you going to copy the thing that you're supposed to know how to get? You can't just copy something that you don't know how to read. So writing code from scratch is practice. Solving problems from scratch, not just the end, not just being like, oh, okay, this is the last step I need to know for, this chemical reaction. Okay, I'm just gonna copy this down. Nope. You gotta go from scratch. You gotta practice from beginning to end, because you have to be very detail oriented when it comes to these things. It's like speaking English. It's like trying to guess the words that someone's gonna say in a book, right? That sounds insane. So take that analogy and apply it to trying to guess what the answer is gonna be to a math problem. It's absolutely crazy to think that you're just gonna be able to guess what is gonna happen in the end. And also, if you just go look up the answers, you're short-circuiting your brain. Your brain's like, oh, I know where to get the answers. You turn to the back of the book, and then you can't do that on the test. So the other thing is practice. Practice, practice, practice. All the time, practice. It's been said that if you can practice anything for 15 minutes for 5 years, you'll be an expert. You'll be among the top 10% experts in that field. So that's just practicing 15 minutes a day. All right, so the things I want to actually highlight in this video are some stuff that really helped me was taking problems, translating them onto a piece of paper into something that was understandable for me, not for the author who wrote the book, not for my teacher. Second thing was going through the book and reading it very diligently and being methodical in the way that I'm reading it. So like going through and planning out what I'm going to cover at the end of it, going back through, covering what I learned, especially in the beginning. The last thing is practicing problems and practicing things from scratch. Because when you do that, you get creative enough that you could go back and possibly reinvent a problem. And if you're reinventing the problem